Welcome once again to the All India ACAS test series solution discussion, and today I am going to discuss test number 7, code A and B, and test dates are 3rd February 2019. So now I am going to start with the question number 1. In the question number 1, a particle is moving along y-axis according to the equation A naught sine 3 omega t. The motion is simple harmonic. So with time period 2 pi upon 3 omega, options are given. So before going to take the option, I would like to say something, because if I compare this equation by the general equation A sine omega t, this is the simple harmonic equation. So if I compare, so I can say the amplitude will be A naught and omega will be equal to 3 omega. So you know that omega is equal to 2 pi upon t, where t is the time period, and that is equal 3 omega. So if I go for the time period, we'll get 2 pi upon 3 omega. So that will give you the time period, and amplitude is A naught. So if I go for the option, then we'll get option number 1 will be the right choice. So let's move on question number 2. In the question number 2, choose the incorrect. So you have to be very careful. This time we are going to select incorrect statement as a correct statement. So statement among the following. Number 1 statement is, at the extreme position, acceleration of the simple harmonic oscillator is maximum. So that option will indicate, first we will discuss some theoretical part. You know the acceleration is minus omega square x. This is the SHM equation and condition for SHM. And you know the velocity in SHM is given by plus minus omega with a square minus x square, where x is the position and a is the amplitude. In the simple harmonic motion, by these two, we can say acceleration is maximum at extreme position. Speed is maximum at mean position, you know very well. Direction of acceleration and velocity may be in opposite direction, right? So by these two we can observe. So now I am going to read the options. At the extreme position, acceleration of the simple harmonic oscillator maximum, yes, this is true statement, but I am looking incorrect statement. At the mean position, speed of simple harmonic oscillator is maximum, yes, true. In the simple harmonic motion, the direction of velocity is always in the direction of acceleration, no, that was not true. So this is the incorrect statement. So we can select option number 3rd. So 3rd will be the right choice. Let's move on question number 3. Acceleration displacement graph of particle simple harmonic motion is given in the figure. Frequency of oscillation. So we need frequency, and tan theta is equal to 8 is given. You know that the equation for SHM is omega square x. So I need the value of omega, because the value of omega will give you the frequency. So how you can solve? Then if I concentrate the slope, then you can see this angle is theta. So I can write m is equal to tan theta, and theta will be 180 minus theta as per the graph. So tan 180 minus theta will be equal to minus tan theta, and as per the question tan theta is equal to 8. So we can take minus 8 is m, right? So now if I place the value in equation number 1, because this is the slope, so I can say the value of m is 8, right? So if I compare with this, so we can say minus omega square is equal to minus 8, right? So omega square is equal to 8 and omega is equal to 2 root 2, because this is the slope of the line. So now if I go for the frequency, because omega is equal to 2 pi f, so f is the frequency omega upon 2 pi, and value of omega is 2 root 2, divided by 2 pi. 2 will cancel, so you will have root 2 upon pi only. So I can say my option number 2 will be the right choice. Let's move on question number 4. In the question number 4, a spring constant K cut into 4 equal parts. This is important question. One part is attached with a mass m, means L by 4 part attached with the mass m. The time period of oscillation. So this type of question you can solve because you know K1 X1 will be K2 X2. You know very well. So X1 and X2 are representing the length of the spring. So in the given situation, I can write Kx, K for spring constant and X was the initial length. So when you will cut, then new spring constant I am writing by K dash and final length will be X by 4. If I go for the situation of the question, then X will cancel out. So I have K dash is equal to 4K. This is how you can calculate the value of K dash. Now, if you are looking to find the time period, because question is asking to us time period of oscillation will be. So you know in the case of a spring block system, time period is 2 pi m by K. This is the formula, but you will write in place of K that is 4K by this relation. So this 4 will come from the root, then 2 will cancel out. The final answer will be pi under root m by K, and that will be the time period. So my option number first will be the right choice. So let's move on question number 5. Question number 5. A particle of mass m execute SHM with angular frequency omega naught, amplitude a naught. The graph of velocity of the particle with the displacement of the particle from mean position will be, and omega naught is not equal to 1. So in the question number 5, you know the velocity in SHM is given by plus minus omega square of amplitude minus x square. So if I take a square on both sides, v square omega square, and according to problem omega naught will be there, and a square minus x square. So if I write like that, omega naught square, this is a square minus x square. So now I can write omega naught square plus x square, that is equal a square. If I divide by a square on both sides, then we'll get v square omega naught square a square plus x square upon a square, and that is equal to 1. So by this equation you can analyze this is equation of ellipse. So without any hesitation you can say the option number 2 means ellipse will be the right choice. So let's move on question number 6.